Hello, hi everyone. Welcome to the Student the Brand. So this is your Siva sir. Today topic is light reflection and refraction. Light reflection and diffraction. So in this we will discuss about reflection phenomena. So we will discuss about reflection phenomena. Light incident on it, it will reflect back. Okay. So incident ray, reflected ray, normal line. And the angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. So we will discuss about reflection of light and loss of reflection. After that, we will discuss about angle of deviation formula. Angle of deviation. After angle of deviation, we will discuss about regular reflection, irregular reflection. And after that, object and image. Object and image. After that, we will discuss about nature of the image formed by the plane mirror. Next, spherical mirrors. So after that, we will discuss about ray rules of concave mirror and convex mirror, and ray rules of image formation. Ray rules after ray rules. So we'll discuss about image formations of convex mirror and concave mirror. After that, we will discuss about sign conventions. After sign conventions, we will go to the lenses, refraction of light. So we will discuss all those points. So check once here. Light reflection and diffraction. Light reflection and refraction. Reflection and refraction. So light reflection and refraction. Okay, so now you can observe here. So light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So when light incidenting on it, so I am taking like this. So incident ray, reflected ray. So here you can observe this is the incident ray, the light which is incidenting on incident ray, reflected ray, and the line which is perpendicular to the surface, that is called normal line. So I am taking this a normal line. This is a normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So once again you can observe incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. And you can observe here angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. So this is the angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. So here you can observe the bouncing back of the light from the reflecting surface. Loss of reflection. Loss of reflection. Loss of reflection. So here you can observe the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. Now loss of reflection. What are the loss of reflection? Here incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. First point is incident ray, reflected ray, normal line lies on the same plane. Point number 1. Coming to the point number 2. Okay, point number 2. So angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. So once again you can observe here. Okay. So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. And coming to laws of reflection, incident ray, reflected ray, normal ray lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So next one, we will discuss about angle of deviation. So we'll discuss about angle of deviation. Angle of deviation. Angle of deviation, if you are taking here, so here you can observe incident ray, reflected ray, now angle of deviation. Angle of incident, angle of reflection, angle of deviation, all are in the same line like linear angle. So 180 degrees. So I am taking this linear angle 180 degrees. I am considering like this. So here angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees, right? So from laws of reflection, we can conclude that angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So that we can write like this: angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Okay. So 180 degrees I am taking here. Now angle of deviation equal to 180 minus 2 angle of incidence. Right? So same thing here. So instead of angle of incidence, if I write angle of reflection, so here I wrote instead of angle of reflection, I wrote angle of incidence. That's why I'm taking like this. So instead of angle of incidence, if I write angle of reflection, then the formula becomes, so angle of deviation equal to 180 minus 2 angle of reflection. So this is about angle of deviation. So angle of deviation formula. Once again, the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Coming to laws of reflection. So incident ray, reflected ray, normal light lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees because linear angle. And here instead of angle of reflection, I wrote angle of incidence. So angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. So instead of angle of reflection, I wrote angle of incidence. So that's why instead of angle of incidence, if I write angle of reflection, the formula is angle of deviation equal to 180 minus 2 angle of reflection. So I hope it is very clear. Now, so we'll discuss about regular reflection and irregular reflection. Coming to regular reflection and irregular reflection. Regular reflection and irregular reflection. So I'm taking the surface here. Okay. So this is the surface, plane surface, reflecting surface. This is the incident ray. So these incident light rays are parallel. After reflection, reflector light rays are also parallel to each other. Incident light rays are parallel, then reflector light rays are also parallel to each other. That type of reflection is called regular reflection. Incident light rays are parallel, then reflector light rays are also parallel to each other. That type of reflection is called regular reflection. So here you can see. Regular reflection. So this is a regular reflection. Incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection. So here incident light rays are parallel, reflector light rays are also parallel to each other. So that's why it is called regular reflection. Whereas here incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. So regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Okay, just check once. Okay, so regular reflection and irregular reflection. Next we will discuss about image and object. So regular reflection and irregular reflection completed. Next one, image and object will discuss. So image and object. Okay. So if you are taking the point of intersection of incident light rays, the point of intersection of directly incident light rays is known as real object. The point of intersection of reflector light rays, the point of intersection of reflector light rays is known as a real image. The point of intersection of extended reflector light rays is known as virtual image. The point of intersection of extended incident light rays is known as virtual object. So those things all we will discuss in the form of diagram. Okay, so let's start. Here once observe. So from here light rays are coming. So the point of intersection of incident light rays is called real object. So after reflection light rays are moving away from it. So we are extending this reflector light rays. Extended reflector light rays are meeting at one. Their virtual image is forming here. So reflector light rays are meeting at one point. So these are the reflector light rays. Reflector light rays are meeting at one point. Their real image is forming. Here we are extending the incident light rays. Extended incident light rays are meeting at one point. That is a virtual object. So by observing these two diagrams, we can conclude that one point. So here you can observe by observing these two diagrams, we can conclude that object is real, image is virtual, object is virtual, image is real. So here from this point light rays are coming. After incident light rays, those are moving away from it. After incidenting light rays are moving away from it. If you are extending this reflector light rays, Extend and reflector light rays are meeting at one point, that is a virtual image. So here incident light rays, after reflection, those light rays are meeting at one point, their image is forming, that is a real image. We are extending the incident light rays. Extended incident light rays are meeting their virtual object. Okay. Here object is real, image is virtual, object is real, object is virtual, image is real. Object is real, image is virtual, object is virtual, image is real. I hope it is very clear, right? Yes. Now next. So next one, we will discuss about nature of the image formed by the plane mirror. So next we will discuss about nature of the image formed by the plane mirror. So let's start. Here I am taking plane mirror. Okay, so I am taking here object here AB. So how many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Okay, minimum 2 light rays are required to form the image of the object. Yes or no? So now you can see here. So if you are extending the light rays, so A dash and B dash, A dash and B dash. So here you can observe object is real, image is virtual. Object is virtual, image is real. So previously we discussed about object is real, image is virtual. Object is virtual, image is real. Okay, vice versa. Vice versa we are discussing. Point number 1. Coming to the point number 2, object distance is equal to image distance. Here you can see the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Okay, so point number 1, first one. So object is real, image is virtual. Object is virtual, image is real. Point number 2. Object distance is nothing but the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance, and coming to the height of the object is equal to height of the image. Height of the object is equal to height of the image. Okay, so be careful, listen. Height of the object is equal to height of the image, and coming to the fourth one, magnification is +1. Magnification is +1, and the next one is so fifth one, it also shows lateral inversion. Lateral inversion. Lateral inversion. Lateral inversion is nothing but, so the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So that mirror image is called lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. Okay, so once again, so nature of the image formed by the plane mirror. So we are discussing now nature of the image formed by the plane mirror. Okay, so object is real. If object is real, image is virtual. If object is virtual, image is real. Image is real. Point number one. Coming to point number two, object distance is equal to image distance. Object distance is equal to image distance. And next one is height of the object is equal to height of the image. After that, next one is magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Next one is lateral inversion. It also shows lateral inversion. What is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So that is about a mirror image. So like a mirror image, plane mirror, we discussed about object and image and nature of the image formed by the plane mirror. And next one, we are going to discuss about one more point, that is spherical mirror. Spherical mirrors. Spherical mirrors are nothing but, so now we can hear. Spherical mirrors, the mirrors which in the form of curved shape, the mirror which in the form of curved shape is called spherical mirror. The mirror which in the form of curved shape is called spherical mirror. Spherical mirrors are divided into two types, concave mirror and convex mirror. So concave mirror, reflection takes place inward. Convex mirror, reflection takes place outward. Concave mirror, reflection takes place inward. Convex mirror, reflection takes place outward. Okay, so that is about spherical mirrors. There are two types of mirrors are there, right? Concave mirror. So now you can observe here. So I am taking the spherical mirror. So like this. So one side is coated, another side is reflecting surface. One side is coated, another side is reflecting surface. Okay, so now you can take. Okay, so after reflection, light rays are meeting at one point. Here you can observe. After reflection, so light rays are converging. After reflection, light rays are meeting at one point. So concave mirror is also known as converging mirror. Here you can observe after reflection, light rays are meeting at one point. So concave mirror is also known as converging mirror. So concave mirror or converging mirror. Converging mirror. So coming to the convex mirror. So here you can see. Here you can observe here concave mirror. After reflection, light rays are meeting. Light rays are moving. So converging. Okay, light rays are moving towards the principal axis. Here you can observe after reflection, light rays are moving away from the principal axis. Light rays are moving away from the principal axis. So concave mirror is also known as converging mirror, whereas convex mirror is known as diverging mirror. Okay, so concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. I hope it is very clear to you. So that's enough. Okay, so concave mirror, converging mirror, convex mirror is diverging mirror. So now, so ray rules of concave mirror. Ray rules of concave mirror. Concave mirror. So now we are discussing about ray rules of concave mirror. So now you can observe here. So before that we will discuss about terms related to spherical mirror. So before discussing ray rules, we'll discuss about terms related to spherical mirror. Okay. So terms related to spherical mirror. Now, so actually this is the center of the imaginary sphere in which mirror is a part. The midpoint of the mirror. So C is the center of the imaginary sphere in which mirror is a part. C is the center of the imaginary sphere in which mirror is a part. So P is the midpoint of the mirror. Midpoint of the mirror. So midpoint of the mirror. The distance between. So the line joining of center curvature and pole is called principal axis. The line joining of center curvature and pole is called principal axis. Point number 1. Okay. So point number 1 is center of curvature, pole. Third one is principal axis. Principal axis. And coming to the fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. So here this one is called radius of curvature. Radius of curvature. And fifth one, after reflection all light rays will meet at one point on the principal axis called focus, principal focus. So here you can observe, after reflection all light rays will meet at one point on the principal focus, principal axis. So here I am taking like this. So F, this is F. And coming to sixth one, the distance between focus to pole. So the distance between F to P. So is called focal length F. Focal length F. And coming to the seventh one, the width of the mirror is called aperture. Width of the mirror is called aperture. Once again, so observe all those points. So C, center of curvature, pole, midpoint of the mirror, and principal axis, line joining of center of curvature and pole. Line joining of center of curvature and pole is called principal axis. The distance between center of curvature to pole is called radius of curvature. So after reflection, all light rays will meet at one point of the principal axis called focus, simply called principal focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And so width of the mirror is called aperture. Width of the mirror is called aperture. So now we will discuss about ray rules. Ray rules of concave mirror and convex mirror. ray rules of concave mirror and convex mirror we will discuss. Okay. So pole, focus, center of curvature, reflection, light rays are passing through focus. Second one, so pole, focus, center of curvature, after reflection, light rays moving towards infinity. So light after reflection, light rays passing through focus here. Here after reflection, light rays moving towards infinity. Okay. So next one, third one. So pole, focus, center of curvature. Here you can observe if the light ray is passing through center of curvature, it retraces its original path, moves in the same direction. Okay. So here you can observe. So coming to fourth one. So pole, focus, center of curvature, light rays incident at the pole, it reflect back into the same medium. Light rays incident at the pole. Okay, so these are the ray rules of concave mirror. So now once observe here, concave mirror ray rules. So light rays coming from infinity after reflection passes through focus. Light rays passing through focus after reflection moves towards infinity. Light rays passing through center of curvature after reflection retraces its original path. Here light rays incidenting at the pole, it reflect back. Okay, so this is about ray rules of concave mirror. Now we will discuss about ray rules of convex mirror. Okay. Now ray rules of convex mirror. Okay, so convex mirror. Now you can see here convex mirror. Light ray is coming from infinity, after reflection moves away from the principal axis here and passes through focus. Here light ray is passing through focus, after reflection moves towards infinity, and here light ray is passing through center of curvature, after reflection it retraces its original path. Here light ray is incidenting at the pole, it reflects back. Okay, so next one. Ray rules of concave mirror and convex mirror we completed. Now image formations we'll discuss. Image formations. Image formations now we will discuss. Okay. Here you can observe object is at infinity, image is forming at focus, nature of the image is real and inverted, size of the image is highly diminished. Coming to the second one. So object is placed beyond center of curvature, image is forming between C and F, nature of the image is real and inverted. So here you can see So object is at infinity. Object is at infinity. Image is forming at focus. Nature of the image is real and inverted. Size of the image is highly diminished. So this is the first case. Coming to the second case, object is placed beyond center of curvature. Image is forming between C and F. Nature of the image is real and inverted. So size of the image is diminished. Size of the image is diminished. So next one. So we'll discuss about third position at center of curvature. So here you can observe object is placed at center of curvature. Image also will form at center of curvature. Nature of the image is real and inverted and same size. So here you can observe object is placed at C, image is forming at C, nature of the image is real and inverted, size of the image is same size because image is forming here. So this is the object and this is the image. Object is placed above the principal axis, image is formed below the principal axis. So this is the object and image. So object is at C, image also will form at C. Nature of the image is real and inverted and size of the image is same size. Coming to here, so coming to in this case, object is placed between C and F. Object is placed between C and F. Image is forming beyond center of curvature. Nature of the image is real and inverted. Size of the image is large. Compared to the object, image size is increased. So these are the two image formations. Next one, object is placed at F. Okay, so Next, we will discuss about one more. That is, object is placed at F. So here you can observe, object is placed at F. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Coming to the object is placed between F and P. Object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. So this is about concave mirror image formations. Coming to the convex mirror image formations. Now we will discuss about convex mirror. Convex mirror only two cases are there. Convex mirror image formations only two cases are there. We'll discuss those two. So pole, focus, center of curvature. Object is at infinity, image is forming at F. Nature of the image is virtual, erect and highly diminished. So here you can observe, object is at infinity, image is forming at focus. Nature of the image is virtual, erect, and highly diminished. Here, object is placed between P and infinity. Image is forming between P and F. Nature of the image is virtual, erect, and diminished. Okay. So next one, sign conventions. So we'll discuss about sign conventions. Now sign conventions we'll discuss. Here, in this case, all measurements will be taken from the pole. In the direction of incident rays, all are positive. Object distance, image distance, focal length, and radius of curvature here. Object distance, image distance, focal length, radius of curvature, all are positive. So opposite incident rays, all are negative. Above the principal axis positive, below the principal axis negative. Height of the image and height of the object. Above it is positive, below it is negative. Okay, all measurements we have to take from the pole. Now I'll discuss in the form of songs. That I will discuss in the form of song. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance positive along the instant rays. Distance negative opposite to instant rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant rays. Distance negative opposite to instant rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. So, one more song also I'll sing. Myopia, 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 near distance distance we can see. Myopia, myopia, myopia. Myopia, myopia, myopia. Further correction, further correction. We are using concave lens, concave lens, concave lens, concave lens. New Cartesian sign a convention, new Cartesian sign a convention. Our distance measure from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative opposite to instant trace. Okay, so that's enough. That is about new Cartesian sign conventions and myopia and hypermetropia. One more song is there related to actually it is related to human and colorful world. Okay, one more I'll discuss. So let's see. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. Further correction, we are using convex lens, convex lens, convex lens, convex lens. Okay, so that is about actually these two songs are related to human and colorful world. Whatever I sang related to myopia and hypermetropia. Now, just now what I sang, that song is related to light reflection refraction. That is new Cartesian sign convention. New Cartesian sign convention is related to light reflection refraction. Myopia and hypermetropia. These songs are I only created just for understanding, so just for remembering and easy way to recall all the concepts. So I created these songs and like different okay. So I am doing like a lot of experiments and still it's going on and related to subject, so that can be helpful any easy way, and they can remember, students can remember like that. I created songs, I designed shirts, like many more still it continues, goes. So we'll see. Okay, so I hope it is very clear. Okay, so next one, refraction of light, we will discuss refraction of light. So let's start. Okay, refraction of light. Okay, so we'll take little break. After that, I'll start a refraction of light. So thank you so much for joining and attending and listening my class. So this is Siva sir from Student the Brand. If you like the channel, if you like the content, if you like the explanation, do like, share, and subscribe to Student the Brand. Thank you so much. We'll see you in the next class. Thank you.